Now see here conversion of galvanometer into ammeter. Suppose you have taken galvanometer here whose resistance is G, and now we have to convert into ammeter, that means we have to use to measure current. For measuring the current it should have the small resistance or the very less resistance. So, what we do here, we connect here the small resistance S, that is called shunt. Then this whole device act as an ammeter. Current I is coming from here, it comes to this junction. Current is divided into two parts, this is here Ig and this is here I minus Ig, and then again comes to this here. So, overall the resistance of this combination has reduced tremendously, it is a very small resistance. So, now this can be connected in series to measure current. So, see here, if you want to measure current I by using this device, so then how much S or the shunt you will be connecting here in parallel. So, what we do here, we know it across this and potential difference remains same because these two are in parallel. So, we can write Ig into G is equal to I minus Ig into S. So, we can write S is equal to Ig into G upon I minus Ig. So, see here this is the S. So, for measuring this particular current I, if you know the resistance to the galvanometer, current through the galvanometer and resistance of the galvanometer, then you can calculate the value of S. Also, you can calculate equivalent resistance in this combination because G and S both are in parallel. So, obviously, the equivalent resistance whatever you are going to calculate, that is here Gs upon G plus S. So, equivalent resistance of the ammeter here. So, now see conversion of galvanometer into voltmeter. So, for this if you have taken here the galvanometer of resistance G and you connect here very high resistance here R. So, the total resistance of this combination has increased to the large extent and this device is known as here now voltmeter. So, see here an ideal voltmeter should have infinite resistance because it should not allow any flow of current through it. Suppose current Ig is going here. So, we can write V is equal to, that is the potential difference across this and this, it means this end and this end, we can write Ig into G plus R. So, we can write V is equal to Ig into G plus Ig into R. So, here V minus I, you have to get the value of R. So, we can write IgR is equal to V minus Ig into G and R is equal to V upon Ig minus G. So, by using this formula you can convert the galvanometer to the any desired range, whatever if the value of the V or the range is known to you. So, the galvanometer is converted into voltmeter by connecting very high resistance in series.